Hello everyone, I am Khyati Desai, and today we are going to learn the new concept of deep learning, that is the history and evolution of deep learning and the applications of the deep learning. So, let's start. First of all, we will see the history and evolution of deep learning. So, deep learning is a powerful subset of machine learning, which itself is a subfield of artificial intelligence. It uses the artificial neural networks with the multiple layers. So basically, deep learning is the concept of artificial intelligence only, which uses the multiple neural networks with which they compose the multiple layers. After that, the history of deep learning is a journey from early theoretical concepts of the artificial neurons in the 1940s to the modern era of complex multi-layered networks driven by the need to solve the increasingly complex problems that traditional algorithms struggled with. So basically, the evolution of deep learning started from the 1940s to till this the modern era. So the deep learning's evolution was propelled by the quest to mimic human-like intelligence, leading to modern applications in areas like computer vision, speech recognition, and the natural language processing. So basically, the evolution of deep learning was propelled to mimic the human-like intelligence. So basically, it was made to mimic the human brain's intelligence. After that, we will see the applications of deep learning. So the deep learning applications are important because they enable machines to solve complex problems that require human-like perception and decision making, such as understanding images and language, driving cars, and diagnosing diseases. So it especially powerful when the data is large and complex. So the large data means we can say as images, text, sound, or large videos. Second is patterns are non-linear or hierarchical. And the third is accuracy and adaptability are crucial. After that, we will see this all the things in detail. So first we will see the history and evolution of deep learning. It began with the idea of simulating human resources in the 1940s, evolved through the mathematical models and algorithms like the perceptron and the backpropagation, and advanced with the availability of the data and hardware that allowed deeper and more complex networks to be trained. The evolution started from the 1940s. So one by one we will see what are the new evolution done in deep learning. So first was early beginnings, that is in 1940s to 1960s. So first was 1943, that was MC Kulak and Pitt's model. Second was in 1958, that is perceptron. Next evolution was the AI winter between the 1970s and 1980s. Third evolution was revival of neural networks, which was done in the 1980s to 1990s. That is in 1986 backpropagation algorithm came, and in 1989 convolutional neural networks came. After that, the fourth evolution was the deep learning revolution, which was in 2000s to 2020. So in 2012, AlexNet came, and in 2014, GAN, that is Generative Adversarial Networks came. After that, in modern era, that is from 2020s till in future, that is in 2020, ChatGPT series came, that is OpenAI, and in 2023, multimodal generative AI came, which refers to like Grok, Gemini, DeepSeek, Cloud, etc. So now we will see the working mechanism of all this. So first of all, we will see the history and evolution of deep learning in detail. So first we will see the early beginnings, which was in between 1940s to 1960s. So first was in 1943, it is MCQLAC and Pitts model, which was made by MCQLAC and Pitts, the first mathematical model of neuron showing how simple computational units could mimic brain behavior. So basically in this model they just showed that how the simple computational units could mimic the human behavior based on the model of neurons. So after that we have second in 1958, that was perceptron, which was developed by Frank Rosenblatt. The perceptron was introduced as an early neural network capable of basic pattern recognition. However, it was limited to solving only linearly separable problems. So basically, perceptron could solve only the linearly separable problems, which was its challenge. After that, the second evolution was the AI winter, which was in between 1970s to 1980s. This refers to the periods in the history when research and development in artificial intelligence, including neural networks, slowed down drastically due to the lack of progress, funding, and interest. So basically, in the AI winter, it is the period in the history in which the research and development was done in the artificial intelligence, including the neural networks. But unfortunately, it slowed down drastically due to the lack of progress, funding, and interest. Third evolution was revival of neural networks, which was in between 1980s to 1990s. And first in that it was in 1986, backpropagation algorithm was invented by Geoffrey Hinton, David Rumelhart, and Ronald Williams, allowing multi-layer networks to learn effectively, which marked the rise of multi-layer perceptrons. So we can say the rise of multi-layer perceptron was basically done in 1986 in the backpropagation algorithm. After that, in 1989, convolutional neural networks came, which was created by Yan LeCun. That was LeNet 5 was created for handwritten digital recognition for image recognition. After that, the fourth evolution was the deep learning revolution, which was in between 2000s to 2020. So in 2012, AlexNet came, which was created by Alex Krihevsky, L.A. Sutskever, and Geoffrey. So it was a CNN that reduced the image classification error by the 50%. So basically in AlexNet, there was a CNN which reduced the image classification errors by almost 50%. After that, in 2014, GAN came, that is Generative Adversarial Networks, which was invented by In Goodfellow. So it enabling machines to generate realistic images, videos, and art. So basically, it was useful to generate the realistic images, videos, and arts. After that, the fifth evolution was done in 2020s to in future till future. So it was a modern era. So in 2020, ChatGPT series came, that was OpenAI. So the generative pre-trained transformers like ChatGPT 2, ChatGPT 3, GPT 4, 5 powered conversational AI, text generations, and coding assistance. After that, in 2023, multi-model generative AI came. So in that, models like Gemini Cloud can process text, images, and audio together, enabling creative tools that generate video, music, or 3D scenes, or even much more. So next we will see the applications of deep learning. So the deep learning applications utilize the ability of neural networks to learn hierarchical features from raw data such as images, sound, and text. So the first application is computer vision, in which it includes the object detection, face recognition, self-driving vehicles. Second is the natural language processing, which includes chatbots, speech recognition, language translations. Third is the healthcare, in which there is disease diagnosis, drug discovery, medical imaging like X-rays, MRI, CT scans, etc. After that, fourth is finance. So in finance, fraud detection is done, stock prediction is done, credit scoring can be done. After that, fifth is cyber security, in which intrusion detection, malware classifications are done. Sixth, we have robotics and automation, in that machine control, path planning, human interaction, etc. is done. After that, seventh point is entertainment, content recommendation, music and art generation using GANs. This we can experience in our day-to-day life also. Whenever we open one of shopping app, in that we are recommended with many different new things. So the challenge was that of history and evolution of deep learning. So the first is limited computational power. Early computers lacked the processing speed and memory needed to train neural networks with many layers or large data sets. So early the processing speed and memory were very slow. After that, second, we have insufficient data availability. Deep learning models require huge amount of labeled data to learn patterns. Before the 2000s, digital data was scarce and hard to collect. Third limitation is that lack of theoretical understanding. For many years, researchers didn't fully understand how or why neural networks worked. AI was seen as unpredictable and unreliable. Fourth is that dependencies on large datasets and GPUs. Although deep learning has advanced, it still depends heavily on massive datasets and high performance GPUs, TPUs, which are very expensive. After that, the challenge of applications of deep learning is that data related challenge. Poor quality or imbalanced data lead to biased and inaccurate models. Second is computational and research limitations. Deep learning training requires powerful GPUs or TPUs, which are very costly and consume large amounts of energy. Third, we have implementation and maintenance issues. So model need regular retraining and maintenance as the data environments evolve. Fourth is ethical privacy and security concerns. So the deep learning models require vast amount of users data, creating privacy risk if the data is misused or leaked. And the last is summary. So in this we learned that the deep learning is a branch of artificial intelligence inspired by the human brain, has evolved from simple neuron models in the 1940s to powerful neural architectures like CNN, GAN, and transformers. Second is today, deep learning arrives innovations in computer vision, natural language processing, healthcare, finance, robotics, etc. However, challenges such as high data requirements, computational costs, and lack of model interpretability will always remain. So the fourth point we learned is that despite these limitations, deep learning continues to revolutionize technology and shape the future of intelligent systems. So thank you so much.